Right. So if you did it, if you use this, let me erase all this and start it again. Yeah. Let's get a little- Okay. Okay. So if you take the benzene ring and then add the acyl chloride with AlCl3, what you'll get is 2 carbons here. You'll get that. And you see I only have 1 carbon there.
Okay.
Does that make sense? So
Yeah.
So what you could do, so the question is, can you do the acyl substitution or just the alkylation? You can do all of them. You just have to make sure that you choose the right group. Okay? So in going backwards here, we know that we need to have a carboxylic acid. Right? And then add the isopropyl alcohol. And do like the Fischer esterification. So in order to get to this, if you remember from the aromatic chapter, you can do it starting with a methyl group and do the caminophore in water. That's the oxidation of a benzylic carbon.
Mm-hmm.
Okay. So, or another way would be is if you started with, if you have an aldehyde there, if you have this aldehyde, and then oxidize it with CrO3 and acid. And in order to make the aldehyde, that's where you do the Friedel-Crafts acylation.
Okay.
But it would have to be a hydrogen, not a carbon. It would be that instead.
A hydrogen, not a carbon. Okay.
Right.
That makes sense.
Yeah, because if you do this, it adds 2 carbons here. So,
Okay.
I mean, you could do that, but it's a roundabout way. You would have to reduce this to the alcohol, like this, and then eliminate it, H plus and acid, to form a double bond, and then you would have to cleave it.
Okay.
So yeah,
a lot more steps.
yeah, it's a lot more steps, but it would still work. And then if you do the oxidative cleavage, it'll cleave this and it'll turn it into the acid, right? Yeah. So
Okay.
yeah. So I mean, you're on the right track. You just have to be careful of your carbon count, of how many carbons
Yeah,
you need.
I think I lost track of my carbons,
Okay.
which I find
Yeah,
I'm doing a lot.
it happens a lot. Yep. Yeah, but no, but I mean, overall, you had the right idea in doing that.
Okay.
Good.
Cool.
Yep.
Thank you.
Yep, you're welcome. I think there was someone else who was speaking right before Andrea was speaking. Was it Anna?
Yeah, that was me.
Oh, okay. Yeah.
I was curious, because as I'm working through the homework, every once in a while you come across like the predictive product questions, and
Right.
some of them it's like I go to the answer booklet and it tells me I was supposed to use 2 equivalents.
Yeah.
It's kind of
Yeah. So I always talk about that in class, where on I will be very specific as to how many equivalents. Yeah, I mean, and it's probably mostly for like the Grignard. Is it probably talking about the Grignard reaction, or is there a specific problem that you had in mind? I mean, sometimes they'll say excess amount. Like if you look at problem 59. Let me pull up the book real quick.
Let's take a look at 44A. That was the one that I was like most.
44A. Yeah, exactly. So actually, I believe that we talked about this one in class sometime. I don't remember when. No, it was probably on here. Where if you see how. Okay. Yeah, I talked about this, but I can talk about it again. So if you have an ester, and let's see, it's 2 carbons. You see how the reagents are the Grignard, and then the second one is acid. If it was only 1 equivalent, it would not have the acid. Right? I don't know if you guys remember, we talked about this last week or the week before. If we only added 1 equivalent here, it adds, first time here, I'll kind of draw a mechanism. Yeah, that the one equivalent stops at the ketone. So I don't have to add the acid into it. So the first equivalent, remember, adds in here. It kicks up to form our tetrahedral intermediate. And then this kicks down and kicks out that group, and you're done at the ketone. Okay? When you add the second equivalent, this is like the previous chapter in chapter 9, where it adds in here, it kicks up, and it stops at that O negative. Then you have to add in the hydrogen, the acid there, in order to protonate that negative charge. So now you have to add it in there. So in this reaction, the fact that they're telling you that you have to add acid is implying that you have to add a total of 2 equivalents.
Okay. Yeah, that makes more sense.
Does that make sense, Jacob? Okay. Yeah. So if they have the acid, I don't. Like I was gonna say, if you turn to page 59, if you look at problem 59, I don't know if everyone has the book, so let me grab the book real quick just so that everyone can see this. Where do I put the book link? Book link, there it is. Let me just pull it up. It'll take forever for it to download. Problem 59, what they say is the word excess. Hey Jacob, can you mute yours because I hear my voice on the feedback?
Oh, yeah.
Yeah, thanks. Right here, you guys see this right here? It says excess Grignard. So that's implying exactly what they're saying. It's more than, it's a lot of it. Okay? So that's kind of what they imply there, an excess amount. Where here, notice it's stopping at the ketone, on this problem right here. It's stopping at the ketone, and they don't add acid, so that's assuming that you're only adding 1 equivalent. See, and then right here, he says, propose a mechanism. What are the products in the reaction with the acid chlorides? So it's implying it's only 1 equivalent. But here, when they say excess, they're implying a lot of it. So again, I would clearly say 1 equivalent or 2 equivalents on the exam. Because otherwise, you're right, Jacob, there's no way that you would know what I'm meaning. But if they put the acid, it's implying it's 2 equivalents. If they don't put any acid, then it's just applying 1 equivalent. All right, so that's a good question. All right, good. All right. What other questions? Otherwise, why don't we just work on these? Have you guys worked on all these? Have you guys done all these synthesis problems? Otherwise, we can work on some of these. I like the last one because there's a lot going on in there. This last one, all of these carbons on this molecule have to come from this molecule. So you can't just add anything in there. They all have to come from this. So why don't we work on this one? I think this is a good one because it incorporates a lot of different chapters. Okay, so just to reiterate, every carbon on this product here has to come from this molecule. Okay, you obviously, you can add as many as you want, but basically everything, so these 3 carbons have to somehow come from this molecule, and these 3 have to come from the molecule. Okay? So I want to give you guys a little bit of time to work on that one. Okay. All right, looks like you guys are done. So, this looks, I think, more complicated than it is. It's really like 3 steps, I think. So, again, in order to make this, always go backwards. Best thing to do is do the very last step, look at the functional group, which in this case is an ester, so to do it, the Fisher esterification is probably the best way to do it. All right. So now I got to make these 3 pieces. If I were to take this, obviously I have to cleave this, so you do the oxidative cleavage, and you form the carboxylic acid. All right, so obviously that piece is for that one, but now I got to get that alcohol, so just LAH it. That's basically it. So it's a 3-stepper. All right, that seem okay? Questions on that? Let's do this one. Oh, actually, it's a bit harder. All right, let's do that one. Again, let me know when you guys are ready. Okay, so in this case, it might be a little harder to go backwards on this one. But you do know, you see that you have all 4 carbons attached to here. So you know that if you add the nitrile onto here, you will get 1, 2, 3, 4. You'll get that compound. It's nitrile, so it gets that carbon on there. All right, and if you hydrolyze this, so first step is sodium hydroxide, second step is adding acid, you convert it to the carboxylic acid. Then you got to LAH it to reduce it down to the alcohol. Eliminate it to get the double bond, and then add acid and water again to hydrate it to give you the Markovnikov compound. All right, so you guys did. I'm sure you guys got that. So I'll make sure that you realize you get the primary, but then you got to eliminate and rehydrate. There is no way really to get that OH on that carbon. I did. Let's see what Andrea said. What did you say, Andrea? I did something different. You want to tell me what you did? We can go over it if you want.
So first I did what you did, I added the nitrile.
Okay.
And then I did 1 equivalent of the Grignard.
Okay.
And then I reduced it down.
Okay, so if you do that, you're going to be adding a 5th carbon onto your molecule. Or, I'm sorry, a 6th carbon. Oh, wait a minute, I'm sorry. 1, 2, 3, 4... 1, 2, 3, 4, 5. Oh, yes, you're correct. Yes.
Oh.
Yes. So what I did was I made a 1, 2, 3, 4, 5. I think I made 1 less carbon. 1, 2, 3. Yeah, I thought I had the same amount of carbons. Yeah, yes. So you guys are correct. So I did it on purpose just to make sure you guys were paying attention. Good job. Good job, guys. You were paying attention. So let me delete all this. So you'll add, and then 2 add acid, and that should leave you the ketone, and then either like sodium borohydride or LAH. Is that what you did? Sorry about that. I thought there was only 4 carbons here. But if there were only 4 carbons, that's how you would do it. 4 carbons was harder than all the other ones. So good. All right, let's do this one. Do that one, and then let me know when you guys are ready. Okay, so this one, you have an amide. So in order to make an amide, best way is the acid chloride. That's what I find is the best way to make amides. So I'm going to make that into the acid chloride. So just going backwards from this one, start with the carboxylic acid, add SOCl2. And then starting from our starting material, do the oxidative cleavage on that H+. Alright, so that makes that piece. And this piece, the amine, I think we've learned a few ways. I think 2 ways. But one of the ways is adding a carbon, so it's the nitrile way. You can add a nitrile, then add an LAH in order to make the amine, but that adds a carbon. We're not adding a carbon, we're just doing a substitution reaction. So this is just a regular SN2. So this is you going through SN2 reaction right here. The other way we've learned is that if you take a nitrile, and add LAH to it, and you can form an amine. However, we're adding a carbon onto it. In this case, we're not adding any carbons. So if you want to make an amine where you don't add a carbon, it's the SN2 of the NH2-. If you want to add carbons to it and make the amine, then you take the nitrile, add LAH to it. Okay? So this is how you guys did it. You don't have anything different that they want to go over? Yes, you had something, Jacob? All right, if you want, you can go off the mic and ask me what you had. Oh, okay. I'm sorry. All right. Good. All right. You guys have anything else, or anything else you want to go over? We can look at these other ones if you guys want to. Are these the blank ones, or are these the... Oh yeah, synthesis prompt. Perfect. Yeah, these are all good. First one looks pretty straightforward. Well, first, are there any other questions about anything? Any other questions you guys have? I want to go to stuff if you guys have questions. I'm only doing this because you guys aren't saying anything else.
Steve, I had a question for you on one of those synthesis reviews that we just did.
Sure. On the one
I believe it was the second one we did on the bottom of the page there, where the first thing is that we cleaved it.
On the last one?
Yeah, right there. So
yeah.
You show us on when we broke it down that you ended up with that second group just ready to go.
Yeah.
And I'm wondering if you want us to show that we're splitting each into its carboxylic acid.
Yeah.
And we're reducing it, and then we're also adding the chlorine on the one.
So you turned it into an acid chloride?
Yeah.
Is that what you're saying? Yeah, I mean, if you did that, then yeah, show that as a separate step.
Okay, I got you.
Yeah, but on mine, I mean, I showed that I made the acid, so I figured I didn't really, and then I just used it later on in the synthesis.
Okay.
Yeah.
All right, great. Thank you.
Yep. No problem. I think all the other ones. I mean, if you guys are good with those, I mean, that's just one more. Actually, we want to. So the only one that we didn't do was this one. You guys, you know what? Why don't we just do it? Let's just finish it off. Let's just do that one next, and then we can go on that other sheet. There's a lot more to it. So obviously, every carbon source on this one has to come from these reagents. Okay, it's quite a bit more involved. All right. Again, let me know when you're ready. All right. So, going backwards, we need to make this carboxylic acid and add it to this alcohol. To make this alcohol, you can do it from the starting material by doing anti-Markovnikov. Sodium hydroxide. To make this, I have to start from the acid, and then CO3 acid. Alright, so I'm using these two things. So, kind of going backwards and forwards. I obviously have to attach this onto here. So in order to do that, I got to first turn this into an acid chloride. And then add it to the aromatic ring to an acyl aromatic substitution to get to the ketone. Then I got to make it a primary alcohol, so I got to move this group over. So you do it in a series of steps. You first reduce it, sodium borohydride, to give you the alcohol. Eliminate it, give you a double bond. And then you have to do another anti-Markovnikov. So you're doing anti-Markovnikov on both of them. All right. I mean, there's lots of different things. If you wanted to make this into a bromine, and then turn it into a Grignard, and then add it to the acid chloride, it would basically make that compound. I mean, there's lots of different things, but that's basically the gist of it. You got to attach this group onto here, move over that group to make the double bond, do the anti-Markovnikov. All right. Anything different? Anybody have anything different? Should be the gist of it. Okay, good. All right, anything else that you guys have? All right, so let's do this problem as our last problem. Let's see if you guys have something else. This is a good one. This one's really going to get you thinking, doing strategy. It's a tough one. All right, I don't know if you guys have done these yet. All right, so make that carboxylic acid. There's lots of ways. Okay, so I'll go on mute, and when you guys are ready, just let me know. Ways of doing this. You just have to plan it out, and you got to be careful that you don't have matching groups and all that stuff. So maybe I'll show you I think what the easiest way would be. So one way that I thought of is you can add HCl, make this into the chloride, add the acetylide to it, which will give you 2 carbons. I'm going to do a few steps here. So do Lindlar's. Lindlar's makes it the double bond. And then, oh no, I'm sorry. No, we need to get 1 more carbon. Hold on 1 second. Actually, I got to think about this. I don't want to do that. I don't want to do the Lindlar's yet. Or the triple bond. What we do is make this into a Grignard, add formaldehyde to it, work it up in acid, you get the alcohol. So I'm doing a few steps here at once. So basically Grignard with 1 carbon, add the OH, make that into the chloride, and then add the acetylide. Give you that. Then do Lindlar's to get to the double bond. Do anti-Markovnikov, BH3, H2O2, sodium hydroxide, give you the alcohol, and then oxidize it. Okay. The other way is you could have the triple bond here. Lindlar's, anti-Markovnikov, and then make it into that alkyl halide. So it's the same type of thing, except it's reversed. So Lindlar's, I'm not going to write it all down. Anti-Markovnikov, 2 anti-Markovnikov, and then 3, turn it into the chloride or bromide or something. All right. Then make it into a Grignard and add formaldehyde to it, and then add acid in order to make that alcohol and oxidize it. Is that making sense? All I'm doing is I'm jotting down all the notes here instead of writing it all over again. I think you guys are able to follow me. That's another possible way. All right, another way. Any questions on those two before I talk about another way of doing it? Anybody do it that way? I did the second way. Okay, good. Another way would be to add acid and water to form the alcohol, oxidize it to form a ketone. Now, we didn't talk much about this, but you can add Grignards that have all different types of groups to it. So, if you wanted to add this Grignard to it, you'd be able to do that. So notice that these 3 carbons, 1, 2, 3, or these, 1, 2, 3, working up an acid. So you would form this alcohol. All right. And then what you could do is anti-Markovnikov it. give you 1, 2, 3, this alcohol. Plus you still have that OH. Then you can oxidize it. Why can you oxidize this and not worry about that oxygen right there? Oxidize it to the carboxylic acid. But why would that OH not do anything? This is a tertiary alcohol, so it wouldn't get oxidized. Then you would eliminate it, H plus an acid. H plus an acid won't do anything with the carboxylic acid, but it will eliminate my OH, my alcohol, to a double bond. Plus you have your acid here. And then hydrogenate. Now this one would be hard to do backwards. You wouldn't be able to do it backwards because you would have no idea that you had to hydrogenate. But this is just another possibility. These Grignards are called allyl Grignards. Remember we talked about allylic, like carbon's allylic. These are very common Grignards that get added a lot. It's a really quick, easy way to add 3 carbons. They're very easy to actually make Grignards, very reactive Grignards. So doing something like this would be a route. You can even add this Grignard. That Grignard has an extra carbon on there. Do all the same thing, but you would do an oxidative cleavage. So at this point, you would have an OH plus this, and then oxidatively cleave it, MnO4 acid. You'd have an OH, and you'd have your carboxylic acid. And then you can go ahead and eliminate and hydrogenate it off. So just another point of view, there's lots of different ways. You can do 1 carbon at a time if you wanted to. So make the Grignard from here. So make the Grignard, MgBr, add formaldehyde to make the alcohol. And then turn that into a chloride, and then eventually into a Grignard. Add formaldehyde again, and make that alcohol. And then same thing, make it to a chloride, make it to a Grignard, and then add formaldehyde to it. Basically, it would make this alcohol. And then you can go ahead and oxidize it up. So you can do 1 carbon at a time. You can put on the whole chunk at one time. You can put in the acetylide and then add all the groups onto it. So I like this one because at this point, really you can use almost any chapter and a bunch of reactions from all the chapters. And lots of different ways of doing it. Another way, I'm going to delete this, if that's all right with everybody. Anyone do something different? Let me show you another way to do it, which I just thought of right now. Would be to take this, turn it into the chloride, just like how we've done. Add the acetylide to it. So it's the same type of thing. H there. All right. Lindlar's anti-Markovnikov. I'll just put AM for anti-Markovnikov. And then that alcohol turn into a chlorine. So SOCl2. So you get this compound. And then add the nitrile. And then sodium hydroxide and acid. From the final product. That'd be another way. Anyone do it that way with the nitrile? Again, anytime you see carboxylic acids and you're adding carbons, think nitriles. You have to do the anti-Markovnikov though, because when you have this group here, you know, that carbon is the least substituted carbon. Right? Or the other way is to take this, it's kind of the opposite of this, add the nitrile to it, turn it into the carboxylic acid, reduce it down to the alcohol, right? I mean, all these ways work. We'll have a carbon OH. Turn it to a chloride. Add the acetylide to it. And then, eventually you'll make that same acetylide compound that we had, that one. And then Lindlar's anti-Markovnikov oxidation. So, 1, 2, 3, 4. That's 5 different routes. Is that 5 different routes? 6 different routes, I think we saw. 6 possible routes. A lot of them are similar. You're adding like the same types of things, Grignards or acetylide ions. All right. Anybody have anything different? If you had something different, I'd be interested to see it. No? That's pretty much what people had. Okay. Okay. Anything else? Want to do one more, or you guys think you're okay? So let's see. So aldehyde and acetylides can replace any halogens. Jacob, why don't you come off the microphone and explain that to me exactly? Aldehyde.
Yeah, so adding that triple bonded carbon, and then you can also add aldehydes, just kind of replace them for any like chlorine or bromine. Or do I have? Is there something specific that does have to be?
I'm not sure I'm following you again. So aldehydes and acetylides can replace any halogens.
Yeah, because that last reaction you added aldehydes and the acetylides, like the triple bonded carbons, to like a couple different spots. I was just kind of curious when we're supposed to use them.
So acetylides add onto halogens.
Right.
We did talk about a few weeks ago that you can add an acetylide to a carbonyl, but I didn't really emphasize that. I'm not sure if you're asking about that. But aldehydes and acetylides don't really have anything in common. They don't really have the same type of chemistry or anything.
So when can we add aldehydes onto?
Well, you don't add an aldehyde. You synthesize an aldehyde from an alcohol. So aldehydes will come from it. So just to make sure that so an aldehyde is this. That's what an aldehyde is, right? So
I meant formaldehyde. My bad.
Oh, formaldehyde. So
Yeah.
so formaldehyde is just a Grignard. So if you just take a Grignard, right, it adds here just like it does. It's basically a way in order to do a Grignard to make and add a single carbon. So this is just a Grignard reaction. So does that make sense? So you can either add formaldehyde, or you can add an aldehyde, or you can add a ketone, or you can add an ester. These are all the things that we talked about that you can add onto a Grignard. But formaldehyde is the same thing as an aldehyde, except R here happens to be an H. Okay? So, like if you have a Grignard, like if you have a Grignard, let's say, MgBr, and you add this aldehyde to it, right, you get this product, right? That's just a Grignard. Now let's do the same thing, but instead let's add this to it. You form that.
Okay, yeah, that makes sense.
Yeah. So it's just a way. It's just a way to actually add one carbon using a Grignard. And then you can take this and oxidize it if you want to into an aldehyde with like PCC or PI, or add like the CrO3 and acid and make it carboxylic acid. So this is just a way to actually add one carbon on there. Okay.
Yes, that was very helpful.
Okay. Yep.
I guess needed like a little distinguishing between the two.
Okay. Yeah. Sure. No problem. All right. Good. Anything else? I have 3 of you left: Andrea, Jacob, and Luke. All right. Well, if you guys are good, I'll post this and I'll see you guys tomorrow. Yep. Luke, no problem. You're welcome. Yeah, Jacob, you're welcome. Andrea, you good?